radius of curvature. This is curve S at point P. This is tangent, which is making angle psi with x-axis. Then radius of curvature rho is given by ds upon d psi. We will understand this concept by an example. But before that, let's write some more formula. The radius of curvature of a circle, that is ds upon d psi, is given by radius itself. Now, the radius of curvature for Cartesian equation, if equation is of the form y equal to fx, in that case, this is equation, this is triangle, this is 90 degree, and so ds, dy, dx. From here, we can write sine psi perpendicular upon hypotenuse, dy by ds, cos psi, it will be dx upon ds. Now, tan psi is equal to dy by dx. We will make use of these concepts later on in different questions. So radius of curvature for Cartesian equation will be given by rho equal to 1 plus first derivative squared whole power 3y2 divided by second derivative y2. But y2 must not be 0. Now, let's take some questions. Question number 1. Find the radius of curvature for S equal to log 6 psi plus tan psi. As we know, radius of curvature rho is equal to ds upon d psi. So we can find ds upon d psi from here. S is equal to log 6 psi plus tan psi. So ds upon d psi, which is equal to radius of curvature, that will be equal to differentiation of this. So if we differentiate this, so it will become 1 upon 6 psi plus tan psi times derivative of this. So derivative of 6 psi is 6 psi tan psi plus derivative of tan psi is 6 square psi. If we take 6 psi common, then tan psi plus 6 psi will be left, and that will cancel the denominator. So we will get a rho equal to 6 psi, and that will be a required answer. Now, let's take another example. We are given S equal to root 8ay. We have to show that a radius of curvature is 4a times the square root of 1 minus y divided by 2a. So we are given S equal to root 8ay. Here, we have to introduce angle psi. So for that, we will consider this triangle, as I told you earlier. This will be dy, this is ds, this angle is psi, this is dx. So sine psi will be equal to dy by ds, similarly cos psi. So let's see which one will be used, and then we will put that value. So s equal to root 8ay implies s square, we are squaring it, 8ay. Now, we differentiate it with respect to s. So 2s will be equal to 8a times dy by ds. And dy by ds is sine psi. So 2s equal to 8a sine psi. We can divide by 2. So s equal to 4a sine psi. Now we know that rho is given by ds upon d side. So we can differentiate it with respect to side. So ds upon d side is equal to 4a cos psi, and we can put cos psi here. We can replace cos psi by sin psi. So we can write it, suppose this is rho, and because ds upon d psi is denoted as rho, radius of curvature, equal to 4a times root of 1 minus sine square psi. Now, from here, sin psi equal to 2s upon 8a, or sin psi equal to s upon 4a. Sin psi equal to s upon 4a. So we can put this value here. So this will become 4a times 1 minus s square upon 16a square. So let's write it further. Here, s square equal to 8ay. So we can replace this s square by 8ay. So we will get rho equal to 4a square root of 1 minus s square equal to 8ay divided by 16a square. So here 8a will divide this 16, 2a will be left in denominator. So rho equal to 4a times root of 1 minus y upon 2a. So this is our required answer. Thank you for watching.